Hello friends, the topic for today is properties of system under the course name Basics of Thermodynamics Part 1. But before proceeding any further, I would like to introduce myself. My name is Harshit Agarwal, mechanical engineer, graduated from NIT Nagpur in 2008. I have cleared the Indian Engineering Services exam. I have got the offer letter from most of the Maharatna and Navratna companies. I have cleared GATE exam. Regarding course fee, there is no course fee as such, yet you can always contribute whatever you feel like. You can also follow me on the specified link. One thing I want to mention over here is before going through this lesson, please follow lesson 1 and 2 for basic thermodynamics because this lesson is linked to lesson 1 and 2 and lesson 1 is regarding thermodynamics word and lesson 2 is system and surroundings. After system and surrounding, lesson 3 is properties of system. As you have all know what is system and what are surroundings. So there are certain properties of a system. For example, the room in which you are sitting is a system. That system has certain characteristics. For example, there is air in that room. It is having some pressure, volume, temperature. Those characteristics are the properties of the system. So the characteristics of a system are known as property. Every system has some characteristics. Every system has some characteristics and those characteristics are known as properties. For example, if your body is a system, your height, your weight, your name, these are your characteristics and we can call it as the properties of your body or the properties of the system. Properties are mainly of two types: intensive properties and extensive properties. Intensive properties are also known as intrinsic properties and extensive properties are also known as extrinsic properties. So intensive or intrinsic and extensive or extrinsic. So students are so much confused that if I say that pressure is a property, right? Pressure is a property, whether that particular property pressure is intensive or extensive, you don't know. Volume is a property, whether volume is extensive or intensive. Temperature is a property, whether temperature is extensive or intensive. Similarly, entropy, specific entropy, enthalpy, specific enthalpy, internal energy, specific internal energy, all these are properties. But what type of question comes in the exam? Question is like this: whether this particular property is intensive and extensive. You need not to learn, you need not to cram these properties. There is a simple concept and very interesting concept to know how you can differentiate whether a particular property is intensive or extensive. For example, this is a simple definition. Intensive properties are those properties which are independent of size of system. For example, intensive properties are those properties which don't depend on the size of the system. I mean, they are independent of the mass of the system. And extensive properties are those properties which depend on the size of the system. I mean, they are dependent on the mass of the system. For example, pressure is an intensive property. I will tell you how this is an intensive property. Temperature is an intensive property. Density is an intensive property. Viscosity, thermal conductivity, these are some of the examples of intensive property. Similarly, extensive property. Mass is an extensive property. Volume is an extensive property. Momentum is an extensive property. Internal energy, enthalpy, these are extensive property. These are some of the examples of extensive property, but we will see in the next slide why these properties are extensive property and why these properties are intensive property. See, whenever a question comes to your mind, whether volume is extensive property, temperature is extensive or intensive, pressure is extensive or intensive, mass is extensive. See, this is an enclosed space or a box or a room. Write those properties inside the box. For example, there are four properties: mass, volume, temperature, pressure. We have written these four properties inside this enclosed space, right? Divide this enclosed space into two equal parts, right? I have divided this enclosed space into two equal parts. For example, this is a room. Divide this room into two equal parts. This is part 1, this is part 2. The property which gets exactly halved, the property which gets exactly half is an extensive property, and the property which remains as it is, I mean the value of the property which remains as it is an intensive property, and the property whose value is exactly half is an extensive property. For example, this is an enclosed volume. These are the four properties. You have divided this enclosed room into two parts, right? Mass will divide it into half, m by 2, right? For example, the volume of room is 100 meter cube. It will divide into 2, V by 2, V by 2. So these two properties are extensive properties. Similarly, temperature, if you will divide this room into half, temperature will not be half, temperature will be as is. For example, the room temperature is 25 degrees Celsius. If you will divide that room into half, the temperature will remain as 25 and 25. So temperature, value of temperature will not change to T by 2 and T by 2. Similarly, if the pressure of room is atmospheric pressure, which is 1 bar, right? So you need to see, pressure will not change if you will divide this room. So the value of pressure will remain changed to P and P. So mass and volume are extensive property, and temperature and pressure are intensive property. Right. This is one concept. Second is, ratio of two extensive properties is always an intensive property. For example, density. The formula of density is mass upon volume. As you have seen, mass is an extensive property, volume is an extensive property. So ratio of two extensive properties, for example, mass and volume, is an intensive property. Mass is extensive property, volume is extensive property, and density is an intensive property. So ratio, keep in mind, be focused, keep in mind, the ratio of two extensive property is always an intensive property, intensive property, intensive property. And the last most important point, specific extensive property, that is specific volume, specific enthalpy, specific internal energy, these all are intensive property. The word, if a word specific is written along with a property, these are all intensive property. Specific volume is what? Volume upon mass. Specific enthalpy is what? Enthalpy upon mass. Enthalpy is an extensive property. Specific enthalpy is an extensive property. Internal energy is an extensive property. Specific internal energy is an intensive property. So whenever you will see the word specific, that is an intensive property, and it is written specific extensive property. Volume is an extensive property, specific volume is an intensive. Enthalpy is an extensive, specific enthalpy is an intensive. Internal energy is an extensive, specific internal energy is an intensive property. So this is a slight idea of what are extensive and intensive property. Now, state of a system. The condition, characteristic of a system is known as properties, and condition of a system is known as state of a system. For example, if you will see this PV diagram, in condition 1 there is some pressure P1, and condition 2 there is some pressure V1. Similarly, condition 2 there is some volume V2, condition 2 there is some pressure P2. So the condition of a system is known as state of a system. This condition 1 is a state of a system 1, this condition 2 is state of a system 2, and the condition of a system is specified by its properties. For condition 1 there are properties P1 and V1. For condition 2 there are properties V1, V2 and P2. As long as the condition is fixed, properties are also fixed. For example, on this particular condition 1, P1 and V1 are fixed. On this particular condition 2, P2 and V2 are fixed. See, change of state is known as property. For example, from 1 to 2 there is a change of state, and change of state is known as a process. The change of state is known as a process. So going from 1 and 2, it is a process. So keep in mind, properties are point function. Properties are point function. Properties will not depend on the path. For example, there is a path from 1 and 2. The value of P1, V1 will remain same. The value of P2, V2 will remain same. If imagine there is some another path from here 1 to 2. Similarly, value at point 1 and value at point 2 will remain same. So next slide is a very important point. Properties are point function or state function. Keep in mind, properties are point function. That means properties does not depend on the path history. If you will go from path A, the value of P1, V1, P2, V2 will remain same. If you go from path B, the value will remain same. Similarly, properties are independent of path history. Properties are point function and state function. And third and the most important thing is properties are exact differential. You can find the exact difference of properties. For example, if you find the change in volume, you can write V2 minus V1. If you want to find change in enthalpy, you can write H2 minus H1. But you can't find change in work, because work is not a property. You can't find change in heat, because heat is not a property. Regarding work and heat, we will discuss later. Keep focusing on my lessons. Keep doing hard work. This is Harshit Agarwal. Thanks a lot.